All right, hey, how's it going? This is Josh, and so this is going to be super crazy because I have students that are watching this. I have people that aren't even in my class watching this, and we're all going to get through this coronavirus thing together, and I'm going to be doing some math. So the way I like to present this stuff, if you haven't watched any of my older videos, is I like to kind of list out some of the work over here and then go through the problems. And so that way, if you're like, dude, I got it, then, like pause the video, move on to the next problem, see if you can do this one, and then check and see what you got. Usually, I honestly think that's some of the best way people can learn, because you're going to learn through your failures. You're going to learn through the mistakes. And so if you're in my class, this is a little bit different because usually we have like the slides and different stuff, but whatever, okay? We're rewriting the situation here, and this is how I'm going to do it, okay? These are the examples from the book, so if you want to follow along, go ahead. But I'm going to bust through all of these, and then, like I said, pause the video, go back and re-listen if you need to, and then if you have questions, just send me an email, send me a message, get in touch, okay? Okay, so let's start with the first one here. And before we get into that one, let me just make sure, like at this point, you're in Algebra 1, you should understand how to FOIL something, you should understand like foiling and factoring and how we go back and forwards with that stuff, right? So if we had two binomials here, x plus 3, x minus 4. Okay, at this point in the game, you should know how to do these, how to FOIL that, I'm going to go quick, okay? FOIL, because at this point, just this is where you should be. And this is where we need to go, is moving on to this stuff, okay? Okay, so anyways, we FOIL this guy. First gets us an x squared, outside gets us a negative 4x, inside is a 3x, and last is a 12, all right? Now, again, I know I went super fast through that, but if you don't understand this part, then I do have other videos on FOIL method. There's plenty of them that are out there, and now our goal is to start factoring these bigger problems. So once you get to this, remember you combine like terms. So then you take these two middle guys here and you get x squared minus x minus 12, and you're done. All right, that's pretty much it. From there, now we got to start looking at bigger problems here, okay? So I just wanted to make sure like you understand what the FOIL method is. And again, like I got a lot of people watching these and asking questions. So I just want to make sure we're all kind of on the same page. And if you think this is going too fast, then let me know, or, get in touch with me, and I'll see what I can do to help you out. Because we're going to be in this till like, who knows when, right? Supposedly our school is supposed to go back at some point, but if it doesn't, I really do want to encourage students to continue liking math. I want you to feel successful in math. Those of you that know my story, I was never good at this stuff, but I have turned it around and I do appreciate this. And at some point, you're going to need pre-algebra and algebra 1. Okay, so at this point, you've gotten this far. Now let's talk about these guys. And like I said, I'm listing these examples here because that's what you can kind of work ahead and do if you're just one of those math masters and you're like, I'm going to take them all on right now. I don't even need this guy. But if you want to do them together, then that's fine too. So let me rewrite this top problem here. We got 27y squared plus 18y. All right. Now, as you're doing these, I think it's really important that you remind yourself that you are working with factors, okay? Everything is a factor or a multiple, I guess you could say. And so there's different methods that books are going to present as to how to get the greatest factor. If you have this guy, you can use any basic calculator, but it's going to work, right? And the numbers are going to get kind of big sometimes. I mean, these aren't too bad, but at the end of the day, if you know up to your 13s, your math facts, that's really what's going to help you out. Because once you get better at your math facts, you're going to just start to see, oh, I can divide them both by this or by this, and then keep on going. So let's do this guy here. Now, when you're busting these apart, that's really what you're doing, is you're looking at the problem and saying, what is the biggest number I can take out of both of these? And most books are going to kind of start in the most basic way and kind of do the factor trees, which I know everybody loves, right? Let me make a couple for these, and then I'm going to talk about a faster way to do it. Because factor trees are always going to work. So I don't want to discount that method, but it does get a little bit time consuming. And so if you can take a little bit extra, like a quick step away from that and just work on the factors, you're going to get through the problems a lot faster. So initially, most books are going to say, just like ours, what are the factors of these things? And they're going to take the number 27 here. And it's a y squared. So we do have y squared, which is how many y's? 2, right. Okay, good. Okay, well, let's take care of this guy. What makes a 27? What two numbers when multiplied make a 27? I guess if I want to use the more technical way of doing this. What makes a 27? I'll do 9 and 3. Are those both prime? No. So then let me factor this guy down and get 3's. Let me do this guy over here. I got 18 and a y. What makes an 18? I got, I'll do 9 and 2. Are these both prime? No. So then I take my 9 here and I factor that guy down as well. All right, so now it's a matter of finding what is the greatest amount of stuff that is common in both of these two numbers, or sets, or parts of the binomial, whatever you want to call it. Okay? And so by labeling them this way, it is pretty consistent. It's a nice way to do these problems. And so, because everything is kind of like mapped out for you. So let's see here. What do I have on this side? I got a 3. Okay, those match. Do I have another 3 that's a match? Yes, I do. Now I got a 3 and a 2, and I can't really do anything else. So now let's move on to the letters. Y's. Do I have a Y in each of these? Yes, I do. Now, maybe you're asking, well, how can you pull out Y's and numbers? And the real reason, or the main reason, I guess, is just because these are factors, right? These are multiples. These are things being multiplied together, however you want to say it. Okay, if I have 2AB, really what we're saying is we have 2 times A times B, and therefore, because they're all multiplied, we're allowed to pull them apart in certain ways. Versus, if this was 2 plus A plus B, I can't just start pulling things out of that because there's some number, some value that I'm then taking and adding to something else. I mean, this A could be like 4 billion. This B could be negative 0.6. I don't know. But I can't just start subtracting or dividing stuff away from this and then reducing the amount. Okay, so then let's just keep on going. Let's see here. So my final greatest common factor here would be I have a 3. And I have a 3, right? Because those are matching in both. I have a 3 and a 3 and a y. Can I multiply these guys together? Yes, I can, because they're all factors. 3 times 3 is 9, and then I have a y. Okay. Now, once I've pulled out the greatest amount of stuff, now I'm just rewriting whatever is left. And so if you're good with those factors and multiples and your math facts and all that stuff, it really does help you move along with this stuff, because then you're able to just say, okay, I have 9y on the outside. What do I need on the inside to make it match if I were to distribute this guy out to everything? Well, I know it's positive or a plus because of this guy here. 9 times what makes a 27? Now, some books are going to teach it 2 different ways, okay? I'm going to go through both right now. Some books are going to say, well, since you've already done the factoring here, the nice thing is that what goes up in here is just whatever is left, 3y. Some books will say, well, 9 times something makes a 27, and you go, oh, it's a 3. Y times a certain amount of y's is going to get y squared, and you just say, oh, it's just y. So initially it is good to do some of them like this and just do the factor trees, because I think it really helps you see what you're pulling out, right? I pulled out this set here of 3s. There it is. I pulled out another set of 3s. There it is. Then I pulled out one value of y. There it is. Then I multiplied all this stuff together and I got 9y. Okay? And then most, like I said, some books then say, okay, well, since you've pulled out everything that you could that was common, now leave whatever's left and just throw it back into the equation. I put in my parentheses because if I were to multiply this, I would want to be able to distribute. This guy has a 3y left, so I write it right there. And sure enough, it works, right? 9 times 3 is 27. Y times y is y squared. And then over here, what do I have left? I guess I got a 2. Okay, so I can just put a 2 right there, and then I'm done. Now, when you're done, I always tell students to check this stuff, okay? Of course, people are like, oh, Miss Rubin, I got this. Josh, dude, whatever, I'm good. But, you know, as the numbers get bigger, it really is worthwhile to check, because we're learning this process so that we can then take it and apply it to other things. And so if you just kind of eyeball it and go, okay, I got it, and then you start working through this math problem with this information that you now have, and it doesn't work, now you got to go all the way back to the beginning and go, oh, dude, like, where did I make my mistake? All right. So take your time with it. I know there's going to be students out there that are like, dude, I know the greatest common factor. Okay. And I know what to do. And if you see it and you get it, then that's great. But be careful, because there's going to be more stuff added in, especially like even with these problems right here, there's more going on. So take your time. Okay. So just to do a quick recap, we got 9y on the outside, right? Because I had a 3 and a 3 and a y. I multiplied those guys together to get my outside number. Then I make my parentheses. And sure enough, if I wanted to check this, if this was the test, right, and I had to do my, write out my answer here, which the book says to use the distributive property to factor each polynomial, okay? So we use the distributive property here to factor this guy. We distributed or factored out the most stuff we could. If I were to go backwards the other direction, by multiplying this times this, I'd get this. This times this, I would get this. Okay? All right. So like I said before, if that one didn't make sense, if I go too fast, then maybe just pause the video and watch it again. See what I did. How did I get these values in here? Is this making sense? Okay. Sometimes it's maybe better to move on to the next problem with me, but you got a couple minutes, right? So take them and see what you get. Okay. Let me erase this guy and let's move on to the next one. So by writing out the factors, like I said, it is a good way to do it, but you know what? I did say I'd show you the fast way as well. So let's do that fast. 27y squared plus 18y. Just look at the two numbers, okay? This is kind of like the abridged version. Look at the two numbers and say, what's the biggest number I can pull out of both of these? Can I pull out a 4, a 5, a 6, a 7, an 8? And if you're good with these numbers, you'd go, oh, the biggest number I can pull out of this and this is 9. And then how many y's can I pull out of both of these equally, right? You can't just take out 2 y's out of this guy and none out of this guy. You got to be able to pull numbers out equally, so that way when you go back and distribute, you get the same answer. So let me pull out what's the greatest amount of y's I can pull out? I got 2 here, I got 1 here. Well, obviously, well, not obviously, but I can pull out 1 y. So I just write my y right here. And then because I'm pretty good with the factors and the multiples and stuff, then I can just rewrite the rest of the problem and be done. 9 times what makes a 27? 3. Y times something makes y squared? Y. I know it's a plus because that's what's right there. And then 9 times what makes an 18? 2. And at that point, I'm good. So that's your final answer. Now that way is definitely a lot faster. If you're allowed to use a calculator, and then I would say this is probably going to be a quicker way for you just to try it and try it and try it. Now I do get students that say, hey dude, but what about, like, let's say I factored out a 3 and then I work with the rest and then it's not correct, right? Because I can factor a 3 out of both, let's say, and then it looks like I'm done, but I'm not. The problem, or I guess what you should do, let's say you pulled out 3y's because you weren't really catching on to this, and you get a 9y plus, what's that, a 6, okay? If your number isn't big enough, the rest of this work is not going to help you when you do other more challenging problems. So what you have to do is, if you've pulled out what you think is the greatest common factor, then you've got to go back and look at these other 2 values right here and see if there's something else that can be busted out of both of those, and then do another level. Okay, it's not pretty, it's not the best way to do these, but sometimes students do that because they're like, oh, the greatest common factor was 3. And then they look at those and like, oh, you can divide both of those by 3. So then you end up with a 3y, you pull out a 3 from both of these again, times a 3, and then you get your final answer down at the bottom, which is what, 3y plus 2. Okay, so you do end up with the same answer. You pulled out a 3y initially, and then you realized, oh, dang, there's another number I can pull out. And then you factor that guy out again. Now you have 3 times y times 3. And because of these properties in math, you're allowed to just multiply 3 times 3 and make it into a 9. All right, and like I said, when it comes to these problems, take your time with them in the beginning, because students will go so fast through these that they'll factor out numbers and go, oh, I didn't realize you could still divide that by 2 or 4 or 7 or whatever. Okay, just look at your final answer inside the parentheses here and see if there's more that needs to be factored out. Okay, I know I'm taking a long time with this first problem, but I really want to make sure that you understand this concept, because if you don't factor out enough stuff, then what's going to happen is you're going to take this part inside the parentheses and keep going with more math. I know that's not what you wanted to hear, but that's what, like, the rest of this chapter is about. And so if you don't factor everything out, you now have a new trinomial or something you're going to be working with. And when it comes time for you to start plugging stuff into a formula and doing things, you're going to get some crazy answers. And then you're going to be like, how did this not work out? And a lot of the times in my classes, what I see is it's because people didn't factor out everything they possibly could out of no matter how many parts you were given. Okay? Just my little public service announcement when it comes to that stuff. I do want you to be aware of where I see students make the most mistakes. Okay? So, here's some more good stuff for you. Again, pause the video if you're not sure or if that went a little bit too fast. I do have 3 more math problems to solve, so let me get going with these things. Man. Okay, the next one here is kind of long, so let me just write this out as big as I can. Negative 4a squared b minus 8ab squared plus 2ab. Okay, so same idea, right? You're pulling out as much stuff as you can that's common with all 3 of these components. And so hopefully you're looking at this going, oh, okay. The biggest number that I can probably pull out of all 3 of these is 2, because this guy has a 2, but I know 8 and 4 are multiples of 2 or factors of 2 or however you want to say it. So let's write that guy down. And then the question is, okay, well, how many A's can I pull out of all 3 parts? Well, I got 2 here, I got 1 here, and I got 1 here. So the most that I can pull out equally out of all 3 of these guys is just 1. And now let's move on to the B's. I got 1B, 2 B's, 1 B. So the most B's that I can pull out of this guy is just 1. And now, because I've pulled out the greatest amount of stuff, now I can just rewrite the rest of the problem. So I'm going to draw my parentheses and then say to myself, self, what do I multiply a 2 by to get a negative 4? Oh, 2 times negative 2. I have 1a, but I need 2, so therefore I can put 1 more in there. And I already have a b, so I'm good. Okay, let's move on to the next guy. 2 times what makes a negative 8? Well, I would go with negative 4. And then we have, do I have enough a's already? I do. So I don't really need to write an a. Or I should say I don't need to write an A. And then I have a B, but I need a B squared. So now I'm there. And then the last part is 2AB, but oh dang, it's the same thing. So because of that, you can't just do 0. And I do have students that want to put a 0 there. I don't know why, but you don't need to. The thing you need to put in there is a placeholder, okay? And this times something is going to get me the same answer, and that is going to be a 1. Because this times 1, if I were to distribute, is going to get me back to that answer. All right, let me just check here, make sure we're good with all of our stuff. This looks correct. Now, some of these problems are going to say factor completely, okay? And so that's where I do have students kind of like on the first problem, they're like, well, dude, I factored out a 3, I factored out my y, and why isn't that right? Because I factored out a 3, you know, I did factor it, but that's where some books and some state tests and all that stuff will say factor completely, and so that's why your answer is technically wrong, because you didn't factor it to the nth degree. You didn't pull out every single thing you could before you rewrote that rest of the trinomial or binomial, whatever it was. Okay, I know it's kind of semantics, but like that's what they want you to do. All right, and it's also going to help you because, like I said, we need this part. This is critical stuff we're going to use later on in the chapter. Okay, so let me erase this guy. Now we're kind of moving, huh? This is not too bad. Thought I'd be here all day. Let's see. Okay, 4QR plus 8R plus 3Q plus 6. And like I said, with these problems, you know, we did the first 2, and now we're moving on to these. If you're noticing what needs to be done, or if I start to talk about the first part of this and how to solve it, pause the video, man. Like, take a second for yourself and say, like, I can do this, and try it. Because even if you try it and you fail it, like, who cares? You know, you're sitting there on your couch, everyone's, you know, at home. Who cares, right? Press play, see what I do, and then go back and go, oh, now I know what I did wrong. You're going to learn so much more by doing that and figuring this stuff out by making mistakes versus just sitting back, watching me do this stuff. In class, I always say, you know, this is not edutainment, right? This is not like, go, Josh, do the math. Like, you got this one. I believe in you. Okay, this is more about you guys learning this stuff versus me just sitting up here doing them, okay? All right, so now that you've learned the factoring, now you need to learn an extra little twist, and that's called grouping. And so you might notice that we have 4 parts. And so as you start to see that, you know, as you start to do these problems in the book, if you see 4 parts, I would instantly start thinking, grouping, gotta start grouping this stuff together. And so what they want you to do is understand that you're allowed to mathematically group these guys together. So let me just kind of put some brackets around them just to kind of show you what we're working with here. Okay? Now, at this point, like I said, if you want to pause the video and then start factoring this, then go for it and kind of see what happens. If you want to watch me and get some hints, then that's cool too. Now, because I broke this into 2 binomials, I'm going to take this guy first, and I'm going to bust this guy apart. So let's see here. What's the greatest number I can pull out of both parts? Awesome, a 4. I don't know why I paused, honestly, because like I don't even know if you're watching this or not, but I got to keep things somewhat interesting for myself because basically I'm sitting in an office talking, and yeah. So what's the biggest number I can pull out here? It's a 4. Okay. And then what's the most of like one of the letters I can pull out? Between QR and R, it's R. Okay. And so now let me just rewrite this equation. Sorry, I got to move my mouse here, make sure I got all my notes. Let me just rewrite what's left. 4R, to make it a 4QR, well, I'm going to need a Q. And what's going to make a 4 turn into an 8 and make it a positive 8? Plus 2. Okay. Now I got to move on to the next guy here. So I got 3Q plus 6. So what is the biggest number I can pull out of both of these guys? I can pull out a positive 3, right? Again, we're talking about factors. So that's the greatest common factor between these two numbers. Okay, and what's left after that? Well, just a letter and a number, right? Okay. Q plus 3 times what makes a 6? 2. All right. So maybe at this point you're starting to kind of see what is going to happen. But if not, just follow along. So I've grouped these in a certain way so that I could break them apart. And by doing this grouping, something happened here, right? This guy became 4R times Q plus 2. And then I have a 3 times Q plus 2. And so the rules of math allow us to regroup this stuff and take the 4R here and group it with the beginning of this problem over here, this plus 3. So I end up with 4R plus 3, and then I end up with a Q plus 2. Okay. And so at that point, I do have my 2 parts, okay? Now, some books with this will say, or some people will say, well, there's 2 of them, so do I need to write it out as 4R plus 3 times Q plus 2 times Q plus 2? And the answer is no. And the main reason is that if I were to do that, I would not end up with this, okay? Because I got 4R, a number, a Q, and another number, if I were to FOIL this guy, I would end up with what's up on top. If I add another Q plus 2, I'm going to end up with this like big old trinomial or polynomial down here that's going to have all kinds of stuff going on, and that just ain't going to work. So that is the reason why, even though I have like a part that I brought together, then I have this guy, I can't just bring down another one. I can't do it, because if I do, it's not going to equal this top part up here. It's really weird because it's almost like you factored something and you have stuff that you need to use or write down, but now it's like your teacher is saying, okay, some of that, if you have duplicates, don't worry about it. Just toss it out the window. I know that's really weird, and there's a lot of students that I've worked with that really was just this trick in their head, because they kept thinking, well, like anything that's here needs to end up in the next row. But I guess think of it this way. Did Q plus 2 arrive in the next row or the next level? Yes, it did. Does it always have to show up more than once? Not necessarily. It's really weird, I know. So, like I said before, pause the video, rewatch this if you want. This is factoring by grouping, okay? All right, let me get my little eraser here and move on to that next problem. Okay, we got 2mk minus 12m plus 42 minus 7k. This one's got a little bit of a twist to it, but I think that if you could get this guy, then this guy should start to make sense, all right? And that's why I'm glad the book did this problem, and that's why I'm glad we get to talk through it. So if you already know what to do, start grouping and factoring and see what you get. Pause the video. I'm gonna work through this guy. I'm gonna group this and this, and this and this. And what can I pull out over here? Biggest number is a 2. Can I pull out m's? Oh, I can. And what's left? Over here I got a k. And then over here, I got a 6. Okay. Over here, I got, what can I pull out of both of those? The greatest number is a 7. And then what's left? I got a 6. I guess I could put a plus sign there. I got a 6 minus k. Okay. Okay. Now, if you got this far and you work through it that fast, dude, you are rocking this stuff. If it took you a little bit longer, or if you're not seeing how I did it, maybe just re-watch this last problem here, because that should talk about how I got to this level. Now, because of this, I got a little situation here, okay? And so what I'm allowed to do is, again, this is really weird, but you are allowed to multiply certain parts of the problem by certain values, okay? And so this is where I can take this and I can multiply it. The book does it kind of weird. I was just trying to look and see, how they listed this out. But really what you're doing is you're taking everything over here and you're allowed to times it by -1. It's weird, I know. And you have this whole thing going on. And up until now, you've always been taught, oh, hey, whatever you do to one side, you got to do the other. Whatever you do to one thing, you're not allowed to just do this. But I'm not technically changing the problem too drastically because I am multiplying it by kind of like a portion of the problem. So this side over here stays the same. But if I multiply a -1 times a 7, I get a -7. If I multiply a -1 times the values in here, it reverses the situation because I end up with a negative times a positive, giving me a negative. And then a negative times a negative gives me a positive. And the reason I did that is because I wanted this guy to match this guy. Let me just rewrite the rest. It's weird, I know. Let's see here. The book says using the associative property, you're allowed to do this. But at the same time, that's just what it comes down to is just a really weird method or thing you're allowed to do when it comes to solving these. Okay, and I wanted to talk about it because sometimes you're going to end up with two different binomials here, and one of them is backwards. And the only way you can really match them up or align them is multiply this series over here by a -1. That way the negative sign, the 1, doesn't change any of your numbers, and the negative sign allows you to essentially switch these two values. But because the 7 is part of the